Hi everybody, I wanted to give you all some homework tips for Knewton this week. If you go through the videos for hypothesis testing this week, we do cover everything that is in the homework, but I just want to make sure that you understand the wording, because sometimes even though it's covering the same thing, sometimes questions can look a little bit different. And Knewton sometimes has a creative way of presenting material. So I wanted to go over some homework examples this week just to help you feel a little bit more comfortable with it. So this week we've got 4 homework assignments. The first one is on terminology and the process of hypothesis testing, then basics of hypothesis testing, analyzing hypothesis tests and research, and developing hypotheses and understanding possible conclusions. Okay, so before you get into this, you want to have watched the other videos so that you'll understand what some of these things mean. But let me jump over to Knewton. And this first section, 9.1.1, preview as a student. And then as always, I always provide like the extra Knewton instruction because I think that can be helpful. Hopefully you guys are finding it helpful. But this section is just talking about claims. And this particular section, I think, is going to help you as you are trying to tweak your research question. These are examples of types of questions that you would ask for hypothesis testing. So this is a good section to go over because it gives you kind of some examples of what questions might look like. So this one says the average amount of time for symptom relief after taking cold medicine is 5 minutes. A pharmaceutical company launched a new cough medicine that brings symptom relief in less time, according to the label. Interested in studying this further, you ask friends who have taken this new cough medicine, and they found that symptom relief did not occur until 11 minutes on average. So you're going to set up the hypothesis test, and they want to know what is the company's claim. So the company, the pharmaceutical, let's say here's the sentence. The pharmaceutical company launched a new cough medicine to bring down symptom relief in less time than the 5 minutes. So the claim the pharmaceutical company is making is that the average length of time for symptom relief is less than 5 minutes. So for these, there's usually a contradiction most of the time in what the norm has been. So the norm average for symptom relief has been 5 minutes, but the pharmaceutical company who has this new cough medicine thinks it's less. So there's going to be a claim in that regard. The claim is usually reflective of an inequality. So in this case, less time. So we choose less. Had it been more time, we would have said greater than 5. And then sometimes they'll give you words like different, and then you would say, that it's different than 5 or it's changed from 5. Anyway, so this whole section is about identifying claims. The next section, basics of hypothesis testing, I believe this one is just coming up with the null and the alternate hypothesis statements and talking about whether it's one-tailed and two-tailed. So basically, left-tailed, right-tailed, or two-tailed, basically that has to do with your alternate statement. It has to do with your alternate statement. So let me just put this up here real quick. So if you'll recall from the earlier videos that you have hopefully watched this week, our null statement could be something like it's known that the mean shoe size for females is size 8. And so then we do a study because someone is claiming that the mean shoe size has actually increased. So it's bigger than 8. So that's our null statement and our alternate statement. So a lot of this homework assignment has to do with setting up those. But we want to know whether this is left-tailed or right-tailed or two-tailed. So here's the way it goes. If it's right-tailed, it's going to be greater than. So like this one. If we had said this instead, less than 8, that would have been your left-tailed. And then if we had did the not equal to 8, that is when it is two-tailed. So the number of tails and the direction of the tails, left-tailed, right-tailed, two-tailed, has to do with the alternate statement. Okay, it's going to match up with that. All right. All right, so going back, this next one is one I really wanted to go over with you guys, just because of the way it's set up. It is analyzing hypothesis tests and research. Oops, bear with me here. I lost it. Okay. Okay, these start off, it has to do with getting to a conclusion. So again, you want to make sure you've watched all the videos, and it also puts it in here with you guys coming up with the alternate hypothesis first. So this one says a manufacturer is looking for ways to increase production of the number of items produced at their factories. It's known that the average number of items produced per week is 914. After opening 2 new factories in the past 6 months, the manufacturer believes the average number of items per week has increased. So if you'll recall, all of our null statements must include an equality, so equal sign. So we know that the mean is equal to 914 will be the null, and the alternate has to do with this claim here that it's increased. So we're going to use the greater than sign, right? So that's similar to what was in the last section homework, but this now takes you to a place where you're actually going to do a hypothesis test with this little Knewton. It's kind of like an applet that they have here. And so for this one, it says, using the information obtained from the previous study about manufacturing, the following data was obtained for the hypothesis tests. And so we have the null and the alternate statement listed, and then there's the significance level, which we have talked about, and then there's a Z statistic, which I have mentioned as we've gone through, because when we calculate this with the calculator, it does give you a Z statistic or a test statistic, and that is 2.92. So let me just kind of show you how to manipulate this applet real quick, and then we'll talk about what this test statistic really means. Okay, so first off, it is mu is greater than 914, so I'm going to start here on the left, and they show left-tailed, right-tailed, two-tailed. So it says greater than 914, so we're going to move this blue dot down to greater than, so you can see shading is on the right. Then over here where it says significance level, that significance level was 0.05, so you're going to slide this slider over to 0.05. Okay, and so then you're going to go down to your graph, and you're going to move this line here, this red one, to the appropriate test statistic, 2.92. So let me talk about what this is. Okay, so if we were to convert the sample mean in this case to, what do I mean? Sample mean in this case to a z-score, that is what your test statistic is. And so that is going to be 2.92. So you're going to just scroll over till you see the test statistic become 2.92. So I'm going to scroll over a good ways. Oh, I overdid it. There we go. Okay, so then it's going to give you a p-value. So the p-value, if you'll recall, is the probability that your sample mean would be as extreme as it is if the null were actually true. And so you can see from this dot to the right, that would be that shading would be representative of the probability, which is 0.0018. Now the purple is shading from what's considered the critical value, 1.645, which is the basically from here to the right, it has a probability of our significance level of 0.05. And so you can see that our p-value is going from the red dot to the right, has a probability that's smaller than our significance level, which is going from this z equals 1.645 to the right. So 0.0018 is less than 0.05. So really all you have to do is look at whether or not the p-value is greater than or less than the significance level. But to find the p-value, you're moving this red dot to the location of the test stat, which is basically your sample mean but converted to a z-score, right? So anyway, you use that to figure out your p-value. P-value is 0.0018, which is less than 0.05, and when it's less, remember we reject the null. So we would choose this one. The p-value is 0.0018, so we reject the null, and that means the manufacturer has sufficient evidence that the average number of items produced per week is more than 914. And there you go. There's one problem right there. Okay, so one more homework assignment for the week, and this one is 9.2.1, and it's developing hypothesis and understanding possible conclusions. This one has a lot to do with the type 1 and the type 2 error. Okay, so just to remind you, a type 1 error is an error. You make the wrong decision, basically. But the decision you make is based off of you rejecting the null. So type 1 is when you reject the null, and it's a mistake. It's an error. Type 2 happens if you make a mistake, and that mistake is failing to reject the null. Okay, so if you can keep that straight, that's going to help you with this section here. So I'm going to click on it. All right, and so then you can watch their little videos on type 1 and type 2 errors in addition to the ones that we've done that I created. This one says a consumer protection company is testing a towel rack to see how much force it can hold. The null hypothesis is that the rack can hold 100 pounds of force. The alternative statement or the alternative hypothesis is that rack can hold less than 100 pounds. What is the type 1 scenario? Okay, so what I would do first is I would kind of write this out and write out what the null is. The null is that it can hold 100, and the alternate is that it can hold less than 100. And this is a type 1 error. And so if it's a type 1 error, the decision that is made is that we're going to reject this null. So I'm going to kind of cross this off. That's the decision we made. We made the decision to reject that. And then this is the conclusion that we make. Because we're rejecting the null, we make the conclusion that the rack is less than 100. But in this case, that's a mistake because it's an error, a type 1 error. So that means that the rack can hold 100. So we make the decision that it can hold less than 100, but that was the wrong decision. We should not have rejected the null. The rack actually can hold 100. So let's see the choices they give us. So the researcher states that there's sufficient evidence to conclude that the rack holds greater than 100 pounds. No, the alternate hypothesis says that it was less. The researcher states there's sufficient evidence to conclude that the rack holds less than 100 pounds of force, but the rack actually holds 100. So that is the one that we would choose. So for this one, I would really encourage you to kind of write out what the null scenario is and what the alternate scenario is. If it's a type 1, you're going to cross off the null and you're going to go with the alternate. And if it is type 2, you're going to cross off the alternate, and basically that's implying that the null could be true, right? So basically you're saying there's not enough evidence to support H1. When actually H1 would be the one that is true in a type 2 scenario. I would just encourage you to take your time with this particular homework assignment just because it's very wordy, and I really encourage you to kind of write it out like I did there, so that you can actually see what the decision and the conclusion would be based off of the type of error. So again, type 1 only happens if you reject the null. Type 2 only happens if you fail to reject the null. And in both cases, type 1, type 2, if we say it's a type 1 or type 2 error, you know that that is the wrong decision, right? So definitely take your time with this one. And like I said, I think it's very helpful to write it out. Okay, so that is all for this little video, but I thought that you might find this helpful. If you have questions, let me know.